Okay, so the agenda for today's session is we're going to cover hash tables, and then inshallah your upcoming lab will test hash tables as well. Usme actually to some extent we will test priority queues too, inshallah, but primarily hash tables. So there are three important schemes that we're going to be going over, two of which you have already covered in class. The third I'm going to introduce and show you a problem regardless, because then the problem is that your next class is on Tuesday and you're gonna have your lab released after class on Tuesday as well. So that doesn't leave us with a lot of margin to go over these contents again. With that, let's get started. So this is the question. A small library wants to store books in a hash table based on their ISBN last two digits, and the size of the table is actually इसको हम M से denote करते हैं. N represents the number of elements in your table and M represents the maximum size of your hash table. So the maximum size that we're given is 12. The books need to be stored represented by their last two ISBN digits. So for each of the following, we're going to insert all these books into the table and show the resulting structure. There are three techniques over here. The first one that we're going to look at, and possibly the simplest one, is chaining. So very quickly, before looking at the hash function, I'm gonna walk you guys over chaining as well. So चेनिंग में ऐसा होता है कि हर इंडेक्स के ऊपर आपके पास एक लिंक लिस्ट होती है essentially. So it's kind of like this. The zeroth index of your table will contain a list. Suppose उसमें ये वाले elements inserted हैं. So just like that, the first index will contain a list, because the thing is कि when you use a hash function, and we use a hash function to decide कि एक element को किस index पे map करना है. We don't store them randomly, we store our elements based on the mapping that our hash function gives us. And it is possible कि sometimes एक hash function दो elements के लिए same index हमें return कर दे. अब फॉर इंस्टेंस हम इस हैश फंक्शन को देख लेते हैं. एच के equals k mod 12. K just represents the key that you're passing to your table. So for instance, इसको मैं key pass करती हूँ 12 की. So 12 mod 12 will be 0. It means कि element 12 को 0th index पे store कर दो. Similarly, if I pass it the key of 23, so it's gonna compute 23 mod 12, which comes out to be 11. So that tells us to put 23 at this index. So it's possible कि जिस तरह आपके पास 12 है and then you have 24, both of them, when their modulus is taken with 12, they give you 0. So this is something we call a collision, when two elements, two keys, are mapped on to the same index in a hash table by a given hash function. And a big part of your discussion on hash tables is simply how to resolve these collisions. So इसके लिए हमारे पास three schemes हैं. The first is chaining. In chaining, what you do is कि आप एक index के ऊपर chain create कर देते हैं and उसमें आप वो सारे elements insert करते जाते हैं that were mapped onto that index. So with that, let's see. Next we have, you're gonna insert them in an order. आप randomly बीच में से नहीं insert कर सकते. You will shortly understand why that is important. So you have 67. What is 67 mod 12? Okay, it's 7. So आप 67 को यहाँ पे insert कर देंगे. Then you have 12. 12 mod 12 is, well, 0, so you're gonna insert it at the 0th index. Then you have the element 89. 89 mod 12 is 5. Then you have 34. 34 mod 12 comes out to be 10. Next you have 78. 78 mod 12 is gonna come out to be 6. Next you have 90. 90 mod 12 also comes out to be 6. तो अब 6 के ऊपर essentially एक chain बन गई है जिसमें 78 के बाद 90 भी inserted है. Next, you have 24. 24 is going to be mapped onto the 0th index as well. So we're going to link it to 12. Next, you have 48, which is also going to be mapped right here. So it's like her index के ऊपर you have a linked list. So this is how you insert in a hash table using chaining as the collision resolution strategy. We're going to look at how you will achieve this in code as well, but before that, are there any questions so far? Okay, all right. Well, if there are no questions, though, with that, let's implement our table over here. So दो तीन operations हैं जो आपको करने आने चाहिए. You should know how to insert into a table, you should know how to remove from a table, and you should know how to search in a table. Remove पे हम दोबारा बात करेंगे. First, let's look at how you're gonna do insertion and how you're gonna do searching in your table. So we're going to define our hash function, of course. Very quickly to tell you guys, M represents the maximum size of your table. In our case, essentially, M equals 12, right? अब जो मैंने table declare किया है, it is a vector, and at each index of that vector, I have a list of integers in order to store elements via chaining. जिस तरह ये वाली आपके पास example है. When I am initializing my hash table, I am just initializing it to a size of m. If I want to represent कि मेरे पास table में जो हर empty slot है, it is represented by -1, and this is a matter of convention. Whatever convention you have to follow is always going to be given to you. Otherwise, you may assume some. अगर मैंने -1 से initialize करना है तो this is how I can modify my function. What that will do is कि वो हर index पे जाके -1 रख देगा. In my case, I don't really need that because I don't need to separately denote that a slot is empty or not. I will talk about this more when we look at our other collision resolution strategies. Chaining में this is not needed. So I have to define my hash function, which is really simple. उसको key pass की है और वो index return करेगा जिस index पे आपने insertion करनी है या आपने searching करनी है. And this is our defined hash function k mod 12. So I will really just return this key modulus 12. Next, I will look at my insert function. Now I can assume कि ये search function मेरे पास available है. So insert के अंदर what I will do is कि first I need to get my index. So index equals, and then I can just do this. इसको मैं key pass करूँगी, it will give me the index, and then I just have to go to that index, and well, I have to insert my element. So मैंने list declare किया. List के लिए you have a pushback function available. I'm inserting into my list my element. And मैंने उसी इंडेक्स पे जाके इंसर्ट किया है. सो essentially if it was 0 तो 0 के ऊपर वो एक एक एलिमेंट को पुश करता जाता. That's what I'm doing. Before we look at insert, let's talk about search actually. So I will pause over here for a few seconds. We don't have many people, so even if no one is gonna volunteer a solution, I would recommend कि आप लोग एक दफा इसको खुद कोड करके जरूर देखें. How are you going to search in this hash table? All right, is someone going to tell me how to go about this? Okay, I'm just gonna add the solution then. So आप essentially यही करेंगे कि first you will get the index, of course. So now I know कि किस index के ऊपर उस element को होना चाहिए जिसकी key मुझे given है. And then what I can do is कि उस hash table के index की list के ऊपर I can even iterate in a loop and I can see if I find it or not. Alternatively, the good thing is कि आपको एक ये function भी given है list का. If I look at find and find को मैं key pass कर दूं, तो वो टेबल के उस इंडेक्स की लिस्ट में जाएगा and it will look for that key. If it finds it, तो it will return true, otherwise it will return false. So I can just simply return this actually. Okay, with that, let's look at remove as well. Once again, I will pause for just a few seconds and I want to give you guys the chance to think about how you're going to implement removal. All right, so once again, we will start by obtaining the index of the element जिसको हमने remove करना है so that we know where to look for it. जब आपने ये element को find कर लिया है, so, well, if you were using your own linked list, or then you could simply take the head of the list, you could iterate over it in a loop, and then you could remove. But हमारे पास, let's say, कि list already implemented है, or we're importing a list for use, in which case you can simply do this as well. Table index dot remove, and then I can just pass it my key. और वो उस टेबल के उस इंडेक्स के ऊपर जो लिस्ट पड़ी हुई है उस लिस्ट में से उस की को रिमूव कर देगा. Are there any questions up until this point? We're done with um chaining. All right, with that, let's move on to words open addressing. I'm just gonna copy these keys over here for our reference so that we know what we're inserting essentially. So अब हमने वही keys insert करनी है in our hash table, but now the hash table that we have essentially uses linear probing instead of double hashing. Linear probing is really straightforward. I can give you the equation for it, but to put it simply, आपके पास अगर एक index आता है for insertion and that index is occupied, you move to the next one. If that is occupied, you move to the next one. And you keep doing that until you reach the index जिसके ऊपर आपने insertion करनी है. If you break it down, it's really just two words, linear and probing. Probing को हम define करते हैं in the concept of hash tables as the number of attempts that you need in order to reach a certain target. Whether that target is where you're going to do your insertion or where you're searching for your element or where you need to remove an element from. So अब हम ये भी देख लेते हैं कि एक की को insert करने के लिए आपको कितने probes required हैं. You can also simply call it attempts. Your hash function is exactly the same. It's just a technique for resolution of collisions. So let's see how we're gonna do that. So first you have 23. We know that 23 comes here. 23 mod 12 is 11. Next you have 34. 34 mod 12 comes out to be, oh sorry, 34 नहीं है आपके पास 67 है, my bad. So 67 mod 12 is going to come out to be 7. Next you have 12. 12 mod 12 is 0. Next you have 89 and 89 mod 12 is 5. Then you have 34. 34 mod 12 is 10. Next you have 78. 78 mod 12 is 6. Then you have 90. 90 mod 12 is. Can someone tell me what 90 mod 12 is? Come on, people. यहाँ पे आपके पास problem आ गई है because 90 mod 12 actually comes out to be 6. Why don't we just write this down over here as well? 90 mod 12 is equal to 6. But the index 6 is occupied. All right, and the thing is कि जब हम chaining कर रहे थे तो हमने simply उसी के आगे उस element को append कर दिया था. Now we can no longer do that. We're doing linear probing. So this is how linear probing works. Sixth index पे हमने insertion करनी थी. The sixth index was essentially occupied. So this is what you do with your hash function essentially. For linear probing, hash function would actually equal k plus I mod 12 for I equals 0, 1, 2, and then so on and so forth. So आप essentially ये करते हैं this is the formula, but in very simple words, you just find the next available index. So अभी मैं sixth index पे थी. This was my first probe, by the way. इससे पहले वाली सारी elements एक probe के अंदर insert हो गई. Which means कि जब मैंने पहला उनका index ढूंढा, तो I was able to find a free available index. So just one probe was needed essentially. Now, my first probe has failed when I was trying to insert 90. In my first probe, I was equal to 0 essentially. So मैंने k plus 0 mod 12 किया था, which was 90 plus 0 mod 12, which gave me 6. So अब I will do 90 plus 1 mod 12, 91 mod 12, which really just means कि look at the next index. The next index is 7, and 91 mod 12 also comes out to be 7, obviously. But 7 is also unavailable, which means that my second probe has failed as well. So then I will do my third probe, and I will do 90 plus 2 mod 12, 92 mod 12, which just means that 7 se agla index dekho, which is 8, and 92 mod 12 also gives you 8, and this is available. So this is where I will insert 90. I am highlighting it for your information to show you कि यहाँ पे हमारे पास collision आई थी और उस collision को हमने resolve किया था. So then I'm just gonna put this in here as well. 90 plus 1 mod 12 equals 7. But then we saw that the index 7 was occupied as well. And then we finally did, oh my bad, 90 plus 2. Oh, that's not mod 12, which came out to be 8. So मैं probes भी लिख रही हूँ. This was the first probe, this was the second probe, and this was the third probe. Sometimes there is a difference in convention, and पहले probe को हम probe 0 भी कहते हैं. But it doesn't matter. Your concept should be really crisp otherwise. पहले प्रोब के ऊपर मुझे एलिमेंट नहीं मिला, नेक्स्ट प्रोब के ऊपर मुझे फ्री स्लॉट नहीं मिला, थर्ड प्रोब के ऊपर आई फाउंड अ फ्री स्लॉट. उससे पिछले सारे एलिमेंट्स वर इंसर्टेड विद इन वन प्रोब. All right, with that, let's look at our next element, 24. So again, 24 को यहाँ पे आना चाहिए था at the 0th index, but it's not available. So I will give you guys a few seconds to insert the last two elements yourself. All right, can someone tell me where these last two elements go into the table? Okay, so जब आप 24 को insert करते हैं and वो यहाँ पे आता है, but this is not available, then you move on to the next index. That's why it's called linear probing, because you're just moving ahead linearly, one step at a time. So you'll insert 24 over here. Then you're gonna insert 48. 48 को so 24 को हमने second probe में insert कर दिया. 48 के लिए the first probe fails because it comes at the 0th index. Then we move one step ahead and that's also occupied, so the second probe fails. Then we move one step ahead and this is free, so it's successfully inserted at the third probe. Are there any questions? Okay, so let's try and implement this in code as well. Hash function मैं यहाँ पे कर रही हूँ define essentially. It's gonna be key modulus 12 once again. This time instead of having a vector जिसके अंदर हर index पे you have lists, now I just have a simple vector of integers because we're not gonna have any lists anymore. So I will give you guys a few seconds to try and work out the insert logic on your own. Otherwise, I will just implement it. But I would encourage you to definitely pause and try this out on your own. Interestingly, it's fine even if we get rid of this क्योंकि हमने उसको modify कर करके use करना है in this example. Okay, all right. With that, I'm going to go ahead and implement this. So this is what I'm gonna do. Now I have to put a loop over here and I have to loop until I'm able to find a slot that is available. But the maximum number of slots that are available in your table is just 12, which is equal to the size of your hash table. And that tells me कि अगर इतने में मुझे अगर like a maximum of 12 probes में या m probes में मुझे कोई slot नहीं मिलता for my element, so that essentially means that my table is full. So I'm going to loop up until only m. So I equals 0, I is less than m, I plus plus. And then at every iteration, of course, I would want to compute the index for insertion. And my index would simply equal, well, the key that I'm inserting plus I initially, which means कि I 0 होगा, and the modulus of that with the size of my hash table, which is 12. And मैंने इसको 12 define किया हुआ है already. So I will find the index and next I will check कि ये index available है या नहीं है. And now I'm going to circle back to something that I mentioned before. For simplicity, I'm gonna put a -1 in here. What that means is कि जब मेरा table initialize हुआ तो मैंने हर जगह पे -1 store कर दिया. That's all it means. Let's change these. It means कि सारी empty slots में initially -1 पड़ा हुआ था. In which case, what I will do is कि if I've computed an index, so I can check that if table का ये वाला जो index है, it is equal to -1, then you can insert at this index. Then table index equals key, which means कि अगर वो -1 है, वो index available है, तो उस index पे मेरी key को insert कर दो. After that, since I'm done with my insertion, so I can actually just return over here. And if I'm able to actually exit the entire loop without doing any insertion, so that tells you that your table was full. And right now, we don't know कि table full होने पे क्या करते हैं. So I'm just gonna print that my table is full right now. In actual, जब आपका table full or rather if it's close to full, you resize the table and you rehash all the elements, but we're not gonna talk about that right now. Okay, all right. So I've printed that my table is full. अगर मैंने -1 से ना initialize किया होता तो भी I could have actually just checked to see if it's null. I have put -1 in place because, well, essentially there are two things that could happen. अगर आपने एक एलिमेंट को किसी इंडेक्स से रिमूव किया है तो you have to be mindful of those slots as well. And then we use a number or a flag to denote that an element has been deleted from there. So that is why actually for simplicity we mention यहाँ पे इसको एज अ कमेंट भी डाल देते हैं, -1 denotes an empty slot, and let's say that -2 denotes that an element was deleted from a slot. Because if an element is deleted from a certain slot, and well, you would have to be mindful of that as well. एक दफा हम अगला function implement कर लेते हैं, and then let's actually circle back to this as well. Just gonna take this to the next page, and let's try and implement search. I will pause over here for a few seconds. I want you to think about how we will implement search. All right, so let's go ahead and implement search now. Um, Search is a lot like insert, so I'm just gonna copy this part over here, and let's work off of this, and then let's see what we need to change. So I am computing my index, ठीक है, and उस index के ऊपर I see if I'm gonna find the element or not. The thing is though, कि once I compute an index, only one of the two possible things could happen, right? Either there is, either I find my element right over there, right? Or I find a -1 over there. अगर मुझे -1 मिल गया है वहां पे, तो that means कि my element does not exist in the table. It means कि मुझे मजीद उस element के लिए search करने की जरूरत नहीं है. अगर वो element exist करता मेरे table में, तो उसको exactly इसी slot में exist करना चाहिए था. So when I encounter -1, I can simply return false. The alternative is that I find my key available. So let's just copy this. So if that index equals to my key, then I will return true. And that is how you will do this. Secondly, अगर आपका पूरा loop exit कर जाता है and you still don't find your element, then you can return false as well, because that meant that your table was full and the element was nowhere to be found in your table. I will give you guys a few seconds to go over this, and an additional minute to try and implement remove on your own once as well. Okay, before we implement remove, now if you have gone over search, I will add one important thing over here. हमने कहा कि हम -2 को use करेंगे to indicate that an element has been deleted. But in search, we are only checking for -1, or we're checking for the key. We're not checking for -2. And this is the thing about having these two different markers for an empty slot and for a slot from which an element was deleted. अगर मैंने एक element को delete कर दिया और उसको भी मैंने -1 से ही represent किया, तो when I am probing during the process of searching, suppose I was searching और एक point पे मुझे -1 मिल गया, I will immediately return false and I will exit my search. द थिंग इज कि अगर वहां से एक एलिमेंट, अगर वहां पे पहले एक एलिमेंट एग्जिस्ट करता था ऑन अकाउंट ऑफ विच आई हैड टू इंसर्ट माय नेक्स्ट एलिमेंट समवेयर एल्स, तो आई डोंट वांट टू एग्जिट एट दिस पॉइंट, आई वांट टू कीप सर्चिंग फॉर इट। लेट मी गिव यू एन एग्जांपल। सपोज कि यही वाला हमारा हैश टेबल है, इसके अंदर if I'm searching for 48, how will I search for 48? I will first go to index 0. I won't find it there, right? That was my first probe. Then I will go to index 1. If I don't find it there either, then I will go to index 2 where I will successfully find and return it. अब सपोज करें कि मैंने 24 को डिलीट कर दिया था फ्रॉम माय टेबल एंड आई डिनोटेड इट विद -1. So now when I'm searching for 48, I will come to my 0th index. I will not find 48 here. Then I will move one step ahead to my first index. और जब first index पे मुझे -1 मिलेगा, तो मैं immediately false return कर दूंगी. It will break my probing sequence immediately. Which is why you have to have a separate marker to denote deletion. We didn't need this in chaining, and so I didn't introduce it then, क्योंकि वहां तो हर index पे एक chain होती है. You don't need to look at -1 or -2 for that matter. इसकी जगह अगर मैंने -2 रखा होता, तो ड्यूरिंग द प्रोसेस ऑफ प्रोबिंग आई वुड नो कि अगर ये -2 के इक्वल है या किसी और एलिमेंट के इक्वल है, तो आई कैन जस्ट मूव ऑन टू द नेक्स्ट प्रोब एंड कंटिन्यू माय सर्च एसेंशियली. Are there any questions up until this point? This is a very important concept in collision resolution. Okay, all right. With that, let's move on. All right. So next I'm gonna implement remove. So that's why I didn't keep a check for -2 as well, by the way. क्योंकि अब मुझे ज़रूरत नहीं है. So let's implement remove. It's gonna be fairly similar as well. I know कि loop मैंने J तक ही करना है. Why don't I just use this actually, and then we'll work our way ahead from this. Okay. So I find the index of my element. उस index के ऊपर I will see कि अगर key present है, तो what do I do? And if the key is present on that index, तो I just have to delete that key. Which in our case simply means कि table के उस index की value को मैं -2 पे set कर दूं. Because -2 indicates that an element was essentially deleted from this slot. All right, and later when it's inserted into this same slot, तो वो -2 automatically change हो जाएगा. Alternatively, what will happen is कि मुझे -1 मिल जाएगा, and -1 simply means कि वो element already deleted है. There exists no element over there. So I can simply return in that case. If we're asking you to implement remove while assuming that the element definitely exists in that table, so you don't technically need this check, because this check just ensures कि अगर element present ही नहीं है, तो what do you do in that case? Similarly, if the loop exits, that means that the element was not present anywhere in the table either, which means that there's nothing that you have to do about it. Are there any questions up until this point? All right, with that, let's move on towards double hashing. This is also a scheme in open addressing. So open addressing में हमने दो चीजें देखी. So actually collision resolution में you have either chaining or you have open addressing. Then within open addressing, you have either linear probing or you have you have double hashing. In double hashing, we have, and by the way, linear probing is just one probing scheme. The thing is that we're just calling it probing. Just like linear probing, you could also actually have quadratic or cubic probing as well. In which case, जहाँ मैं k plus I कर रही हूँ, वहाँ मैं k plus I square या I cube कर दूंगी, for instance. Anyway, in double hashing, you use two hash functions. There is a primary hash function and then there is a secondary hash function. It's really easy to understand as well, and I really want you all to be familiar with this resolution scheme as well. So, this is what we're doing. The problem is still the same. You have to compute the index जिसके ऊपर आपने अपने element को जाके place करना है. So you take your primary hash function h of k और आप वो compute कर लेते हैं. Then you also compute this secondary hash function d of k. आप इसको भी compute कर लेते हैं. There are some restrictions. We're not going to talk about them right now. Since you are still to cover this in class, I will just show you how to apply it essentially. So hk and dk हमने ये दोनों hash functions compute कर लिए for that key. And in linear probing, this is what you were doing, right? आपने hk compute किया, आप plus कर रहे हैं j and then आप उसका modulus ले रहे हैं. या आप essentially अपनी element में ही उसको push कर रहे हैं, which is gonna give you one and the same thing in the result. In this, what you're doing is कि आप j को multiply कर रहे हैं by dk and then you take the modulus of that with 12. For j equals 0, 1, 2, and of course, those would be the number of probes that you need. Let's try this out and then this will make a whole lot more sense. So let's get started with 23. For 23, hk equals, well, that's h23. So what is 23 mod 12 going to give you? It's going to give you 11. Similarly, you will compute dk as well, which is 8 minus k mod 7. So what is 23 mod 7 gonna give you? It's gonna give you 2. So 8 minus 2, which is equal to 6. अब पहले प्रोब के ऊपर j 0 है, which means कि ये 0 से मल्टीप्लाई हो जाता है, which means कि सिर्फ hk mod 12, which means just hk. All right, so for the first probe, the index will equal 11 plus 0 times 6. So 0 times 6 essentially just means कि पहले probe के ऊपर आपको ज़रूरत नहीं है दूसरे hash function को देखने की, just like we've discussed already. And then the modulus of that with 12, which is just 11. So 23 को मैं 11th index पे insert कर दूंगी. Similarly, then I have 67. I will only do this for a couple of examples, not all of them. So for 67, 67 mod 12 comes out to be, it comes out to be 7, right? Yeah, it comes out to be 7. And then I'm gonna have dk, which is 67 mod 7, which is gonna come out to be 4. So 8 minus 4 is essentially equal to 4. To compute the index, I will just do 7 plus 0 times 4, which is just 7. So मैं इसको 7th index पे insert कर दूंगी. Alright, next I have the element 12. Now I'm not going to do this math again because we understand it well enough. 12 के लिए 12 mod 12 is 0, so I'm just going to insert it at the 0th index. Next, I have the element 89. 89 mod 12 is gonna come out to be 3 essentially. So I'm gonna insert this at 3. Sorry, not 3, it comes out to be 5, my bad. Next, I have 34. 34 mod 12 comes out to be 10, so I'm gonna put it over here. Then I have 78, and 78 mod 12 comes out to be, it comes out to be 6, so I'm gonna insert this here. नेक्स्ट आई हैव 90। अब 90 पे हमारे पास प्रॉब्लम आ गई है बिकॉज 90 के लिए भी सिक्स्थ इंडेक्स ही आता है which means that now we have to find a way to resolve this essentially. So let's see. For 90, HK is gonna come out to be 6. DK is going to come out to be 1, right? Yeah, it's gonna come out to be 1. So when we look at our first probe, the index is gonna be equal to 6 plus. Now, for the first probe, I'm just multiplying it by 0, and I already know that my sixth probe is gonna fail because, well, we've already seen that, but I'm just putting this over here for your information. So this comes out to be 6. The sixth index is obviously not available for us. So I'm gonna move on to my second probe. Now I just keep multiplying these by, j equals 0, 1, 2, and so this is going to come out to be 7. 6 plus 1, 7. 7 mod 12 is 7. And the seventh index is essentially not free either. So I'm gonna move on to probe 3 then. अब मैं इसको 2 से multiply करूँगी. See, this is the only thing that is changing essentially, which is why I said it's not that hard to understand. So 6 plus 2 is gonna give me 8, and 8 mod 12 gives me 8. And the 8th index is available, तो 8th index पे जाके मैं 90 को place कर दूंगी, and I needed exactly 3 probes to find a place for 90 successfully. Next, you are inserting the element 24, and I know that 24 is going to be problematic for me as well, because 24 initially यहाँ पे जाता है, and this slot is already occupied. So let's do the same thing for 24. HK comes out to be 0. What does DK come out to be? So 24 mod 7 is 3. 8 minus 3 is 5. This is what changes. So 6 plus 0 times 5, obviously this is, sorry, ये भी 6 नहीं है, ये 0 है. So this is going to be 0. We already know that this has failed. This one is going to be 5, and 5 is also occupied, so this is going to fail as well. This one is going to be 10, and 10 is unfortunately also occupied, so this probe fails as well, which means कि हमें एक fourth probe करने की ज़रूरत है. So let's see. At the fourth probe, this is gonna be 3, and 3 times 5 is 15. 15 mod 12 is 3. अब मुझे third index पे fourth probe में I have been successful. So I'm gonna place 24 at the third index. Next you have 48. 48 is once again gonna be problematic क्योंकि ये इस index पे आता है by default. So let's do the same thing for 48. I will pause over here for a few seconds and I will let you guys try this out on your own as well, in fact, because it's good practice. One of these I'm gonna get rid of over here to make some room. ठीक है, so हम देख लेते हैं for 48. HK comes out to be 0, I know that. And what is 48 mod 7 gonna give me? It will give you 6. So 8 minus 6 is actually 2. So this is what changes. यहाँ पे मेरे पास 0 आया, the first probe was a fail. यहाँ पे मेरे पास 2 आया, so my second probe is actually a success. I will place 48 over here. Are there any questions up until this point? Because this is a really important concept. Are there any questions? Okay, on that note, we're going to move on and we're gonna try and implement the exact same thing in code now. These are two things that actually three things that I am copying over here, and let's be mindful of them while we implement this in code. So the exact same thing, मेरे पास एक vector है integers का. I don't have a list क्योंकि I don't need a list like we discussed. You're gonna define hash function 1 and you're gonna need to define hash function 2 as well, which is really simple क्योंकि ये हमें given है already. So hash function 1 is just gonna return key mod 12. Hash function 2 is going to return 8 minus key mod 12. So these are both of my hash functions. Now I want to implement insert. We've already discussed the scheme that we're gonna be following. So I will pause over here for a good 30 to 40 seconds. I want you guys to try this out on your own. Let's keep this in mind कि आप probe कर किस तरह से रहे हैं. This is how you're continuously computing the indexes. So let's just paste this over here actually. Okay, is someone gonna tell me how to do this or shall I just go ahead now? Okay, I'm gonna go ahead and implement this then. दोनों hash functions आपको given है. So what I can do is कि I can compute, मैं h1 h2 भी कह सकती हूँ, but if you want to follow exactly जो हमने यहाँ पे दिया हुआ है तो you can also just call it h and d. So int h will give me the index that is obtained by my first hash function 1, and then perhaps I can just call it int d since that's the convention that I followed over here. So then you can say hash function 2 key. So इस तरह आपने h और d तो obtain कर लिया है. The only thing that changes is j now. We've um tried solving this as well. So I'm gonna loop over my table, of course. Similarly, I'm gonna do it up until m because m means कि मैंने सारे table को explore कर लिया. So int I equals 0. Rather, यहाँ पे अगर j given है तो we'll just follow j for your ease as well. So j is less than m, j plus plus. Now I'm going to compute the index. जिस index पे मैंने search करना है, and for computing that index I'm already given this formula that I have been following consistently. So I know what h is and j से मैं multiply कर दूंगी d को. I've already computed d as well. And then I take this entire thing and I take its modulus with 12 and that gives me the index. So essentially this exact thing. And आगे से your insertion criteria is pretty much the same actually. So I will say that if table के उस given index के ऊपर -1 पड़ा हुआ है या even -2 पड़ा हुआ है actually, so I'm gonna overwrite it with my element that I'm trying to insert into my table. Oh, and since I've inserted my element into my table, I can just exit over here as well. अगर आप exit नहीं करते, तो like we said, it means that your table was full. All right, are there any questions up until this point? Okay, so we're gonna move on then. We're going to try and implement search as well and then remove as well. अच्छा remove यहाँ पे given नहीं है, but we're gonna insert search and remove anyway. You guys are welcome to try this out on your own as well. In the best interest of time, I'm just gonna add the solution here. So searching is pretty much like insertion. मैंने दोनों calculate कर लिए indexes and then I check if this is -1 तो I will return false which means कि मुझे element कहीं भी नहीं मिला. दूसरा केस इसका ये था where let's just add it over here. If it is equal to key, then I will return true. So exactly the same way that we were doing in linear probing. अगर loop exit हो गया है and you still haven't found the element, it means you've looked at the entire table and you can just return false now. Okay, I will pause for a few seconds because I do want you to try and implement remove on your own and then we will move on. Okay, so once again for remove, this is what I've done. मैंने index obtain कर लिया. Once I have obtained the index, so I check if it's equal to -1, so that means I can just return वो element exist ही नहीं करता था. If your remove function once again assumes that the given element does exist in your table, so you don't really need this check. These are the checks that you do need though. If it is equal to your key, तो आप उसको overwrite कर देंगे with -2 to indicate that an element has been removed from that slot. And then you can exit your function as well. All right, are there any questions up until this point? Okay, so we've pretty much implemented all the functions that are important to you. इसके अलावा आपके पास एक concept है hash table में. We haven't covered it in detail right now, so we haven't done it in code either. And I want you guys to definitely try this out. I would encourage you to do it. Um, after your given lecture. We're probably gonna need you to do it in your upcoming lab as well, because this is an important part of hash tables. So जब आप एक एलिमेंट को इंसर्ट करते हैं इन अ टेबल, हमने ये देखा कि जब टेबल फुल है तो हम आउटपुट कर देते हैं दैट द टेबल इज फुल. चेनिंग में वी डोंट नीड टू डू दिस, बट ओपन एड्रेसिंग में वी हैव कंसिस्टेंटली डन दिस. Where is it? Yeah, here we go. So the table is full. In actual, you don't do that because initially you declared a certain maximum size of the table, and then what you do is कि आप एक element को insert करने के बाद देखते हैं कि hash table में कितने elements हैं. अगर एक certain percentage से ज़्यादा उस table की occupied है, filled है, तो then you would resize the table. फिर आप उसके size को increase कर देते हैं. And this really depends on the criteria and the convention that we're following. Typically what we do is कि हम उस hash table के size को double कर देते हैं. So अगर hash table में initially for instance 12 का size था and 10 elements are inserted into my table, so then I could just put a trigger कि अगर 10 elements inserted हैं या अगर मेरा 80-90% table whatever threshold I specify कि अगर मेरा इतना percent table full है तो I would immediately double the size of my table, and doubling the size of your table would mean that your all your elements would need to be hashed to new slots because your hash function would change accordingly. हमने अपने hash function के अंदर hard code किया था modulus 12 को. In actual, you are likely taking the modulus with the size of the hash table. So mod m. We did this for simplicity. So जब आप resize करेंगे तो आपको सारे elements दोबारा insert करने पड़ेंगे, which tells us what that resize is an expensive operation in hash tables. इवन दो इन द एवरेज केस आप इंसर्शन भी कांस्टेंट टाइम में कर रहे हैं, क्योंकि प्रोब्स आपको मैक्सिमम भी जो प्रोब्स करने पड़ेंगे वो एम प्रोब्स करने पड़ेंगे विच इज इक्वल टू द साइज ऑफ योर टेबल. And typically, when you have a good hash function defined, so either your element will be inserted immediately or you will just need maybe like two or three probes at best. जितनी भी हमने इंसर्शंस देखी उनमें हमें 3-4 probes से ज्यादा कहीं भी नहीं लगा, and that was hardly for like an element or two. So if you have a good hash function defined, you won't need a lot of probes, which means that insertion will happen in O of one time in the average case. Similarly, since you're following the exact same approach, so searching will happen in O of one time in the average case. Removal will happen in O of one time in the average case. So it's a really nice data structure. लेकिन insertion के लिए जब आपने resize और rehash करना है, तो फिर you will actually be, then in the worst case it's O of n, जब आपको एक एक element को rehash करना पड़ रहा है. ये जो हम proportion calculate करते हैं, we call this the load factor. The load factor has been introduced in class as well. So the load factor of a hash table, it is represented by alpha, by the way. So load factor alpha equals the number of elements that are in your table divided by, oh my bad, the size of your table divided by the number of elements in your table. अब हम अगर compute करके देखें इसको, for instance, इस एक एग्जाम्पल के लिए करके देख लेते हैं, so that this is a little bit more clear to you as well. In this case, the size of our table is 12 and the number of elements that are inserted into our table are 1, 2, 3, 4, 5, 6, 7, 8, and 9. So this is what your load factor is going to come out to be. अगर हम इसको define कर दें, for instance, कि if your load factor is greater than or equal to 1.5, then you're going to rehash all the elements in your table. So that is the criteria that you will be following. Are there any questions up until this point? Okay, with that we're going to move on. So हमने implementation level पे देख लिया है hash tables को. Let's look at an example where you are using hash tables, and there are several problems that you can do in really good time just using hash tables. So this is a really important data structure to us actually. So you are given an integer given an array of integers, just one small thing. It is possible कि आप लोगों ने जो load factor के लिए convention follow की हो, that is the number of elements over the table size, m over n or n over m. So I will double check this and edit this over here. Just a small point to add. Okay, with that, let's look at an example where we can use hash tables effectively. But first, we'll figure out a basic solution. So you are given, and this is a lead code problem, by the way. You're given an array of integers, numbers, and an integer target. Return the indices of the two numbers such that they add up to a target. You may assume for simplicity that each input would have exactly one solution, and you may not use the same element twice. You may also assume that only one valid answer exists and you can return the answer in any order. और let's suppose कि हमने as of now सिर्फ वो दो numbers जो हैं वो print करने हैं या उन्हें return करना है जिनके लिए ये exist करता है. Even if we just want to print them, I mean. So let's look at an example to understand this better. ये आपको numbers की एक array given है and the target is 9. So you have to find two numbers in this array such that they sum up to 9. It's really as simple as that. And you are told कि सिर्फ एक ही valid answer exist करेगा. In this array, for instance, only 2 plus 7 is gonna give you 9. So your output is 0, 1, 0th index and the first index. आप इसको simple रखने के लिए दो elements भी return कर सकते हैं जिनके लिए this is true. But that's basically up to the problem statement. Similarly, you have another example. The array is 3, 2, 4 and the target is 6. So 2 and 4 sum up to 6. इसीलिए हमने index 1 और index 2 return किया. And then if this is your array, the target is 6. So of course both of these elements add up to 6. So you have to find these two elements. Let's try and figure out a naive solution to this जो हमारे mind में initially solution आता है to solve this. How will you do this? If someone would like to tell me what you will do in brute force, so I would be happy to hear your solution as well. Okay, would someone like to add to this before I add the solution? So इसका essentially एक naive solution तो ये बनता है कि I just try all possible combinations to find the one that works because I've already been told कि एक ऐसा combination exist करता है that will work for me. So one for loop, second for loop to try all combinations. And then the first thing that I obviously need to make sure of is that I is not equal to j, because then I'm just checking the same element. So if I is not equal to j and nums I plus nums j is equal to my target, so then I can just return I and j, जो indexes मैंने return करने थे, or I could return those elements. Can someone comment on the time complexity of this solution? तो आप दो loops लगा रहे हैं ना? Time complexity is gonna be O of n square. Guys, time complexity is like really important in data structures. जो आपको question given होगा, typically उसमें either you are asked to comment on the time complexity of the algorithm or you are asked to implement a solution within a given time complexity bound. So anyway, I will give you a minute to think of how you can do better than this by utilizing a hash table. अभी हम n square में काम कर रहे हैं, so how can we do better than n square? Why do we need these two loops anyway? So I will iterate that the cool thing about hash tables is that they make searching a lot easier. You can search and O up one time in the average case. With that, I'm gonna pause for a minute and then we will solve this. This is our last question for today. All right, with that, I am going to solve this now. So हम hash table को use करेंगे and let's see. which means that the first thing that you need to do is that you need to put all your elements in the hash table, right? So suppose कि मैंने एक hash table declare कर लिया and then एक loop के अंदर मैंने उस hash table में सारे elements insert कर दिए. So for I equals 0, I is less than n, I plus plus, where n is the size of the nums array that you've been given. Hash table. अच्छा मैंने hash table को suppose के इस size से initialize कर लिया. This is what I needed. So dot insert. अब मेरे पास ऊपर insert, search, remove ये functions implemented हैं already. So मैं इसमें एक एक number को insert कर लूँगी. Okay, so my first loop for inserting. In my second loop, this is what I will do. I is less than n, I plus plus. So अब मैंने एक given element पकड़ा है. Suppose कि that element was equal to, let's just take an example. Yep, let's just work with this example. Suppose कि मेरे पास ये वाली example थी और सबसे पहले मैंने ये element 2 को देखा है, right? So I just need to check कि 9 minus 2 which is 7 क्या वो exist करता है मेरे table में या नहीं. I can do that for all the elements. जैसे when I do it for 9 minus 11 or 11 minus 9. So I can see कि, oh, hold on, my bad. Jasira, you are doing 9 minus 2, you're gonna have to do 9 minus 11 here, and 9 minus 11 comes out to be minus 2. But minus 2 doesn't exist in my table anywhere. So this is how I can do that. If table, your hash table, dot अब टेबल में मेरे पास search का function available है, right? We implemented it and we know that it works in O of one time in the average case, which is just constant. So if I can search for an element that is equal to the target minus the current element that I'm standing at, so it means that I've already found the combination that I was trying to look for, right? बट मुझे ये रिजल्ट स्टोर भी कहीं पे करने हैं तो आई एम जस्ट gonna declare these two over here, all right? So अगर ऐसा होता है तो num1 will equal nums I, right? And num2 will equal nums I target minus nums I essentially. Now I know कि ये वो दो elements हैं जो मैंने अपने table में से निकाले हैं. So what do I need actually? My question requires me right now to not return these two elements but to return their indexes. So index के लिए मुझे एक दफा loop करना पड़ेगा actually. I can just store that result somewhere. So for int I equals 0, I is less than n, I plus plus. Just one simple condition, if nums I equals nums1, or even if it equals nums2, I mean. Num2, then I will result dot append, and I will just append the index, and then I can just return that result, right? So this is how I am doing the exact same thing using hash tables. And even though मुझे एक hash table declare करना पड़ रहा है and मुझे 3 loops लगाने पड़ रहे हैं, अगर आपने सिर्फ numbers return करने होते तो even 2 loops would suffice actually. So even if I have to do this, my entire solution is actually running in O of n time. And जो previous solution था उसकी time complexity was actually n squared. So whenever you have a problem that involves searching, you should know that hash tables may make your problem a whole lot simpler. With that, that's going to be all for today. Are there any questions before we conclude?
मैम डेटा स्ट्रक्चर से रिलेटेड नहीं था। जनरली आपसे एक चीज़ पूछनी थी मैंने।
यस मोहित।
मैम जिस तरह डेटा साइंस के अंदर मैंने कोर्स किया था तो उसका ग्रुप के प्रोजेक्ट एंड पे प्रोजेक्ट एक किया।